Hello and welcome everyone. This is Shruti Kurana on behalf of TCS iON. I welcome you all to this free masterclass where we will talk about natural language processing. Today we are diving into the fascinating world of natural language processing, how machines are learning to understand, interpret, interact with human language. We will explore how NLP is transforming industries by enabling applications like chatbots, language translation, sentiment analysis, and many more. From the basics of text processing to advanced techniques in language modeling and speech recognition, this session will provide a comprehensive overview of NLP. Whether you are new to the field or looking to deepen your knowledge, this master class will equip you with the practical insights and skills needed to thrive in this exciting, rapidly growing area. I would like to introduce Dr. Firdaus here. I hope Dr. Firdaus.
Yes. Hello.
Hi, Dr. Firdaus. How are you?
I'm good. Thank you.
So, I'm thrilled to introduce our experts for today and welcome Dr. Firdaus. So, let me give a brief introduction about you. Dr. Firdaus currently works as an assistant professor in the Department of Computer Science and Engineering at IIT ISM Dhanbad. Previously, she was a postdoctoral researcher in the Department of Computing Science at the University of Alberta, Canada. She has earned her PhD from the Indian Institute of Technology, Patna in 2021. Her primary research focus lies within the domains of natural language processing and dialogue generation. Over the past 7 years, she has dedicated her research efforts to natural language processing, information extraction, and machine learning, yielding substantial contributing in these fields. Dr. Firdaus has authored numerous papers presented at esteemed conferences such as AAAI, IJCAI, and many more published in distinct journals, including Expert System with Applications, Knowledge Based System, ACN Transactions. And she has delivered tutorials also at IJCI, ECIR, etc. on the topic of empathetic dialogue systems. So it's an honor and pleasure to have you in our session today. Once again, a very warm welcome, Dr. Firdaus.
Thank you so much, Shruti. Thanks for the warm welcome and introduction.
So now I would like to ask Dr. Firdaus that we have a diverse mix of audience from both IT and non-IT background, each bringing unique perspectives and skills. Given this variety of audience, can you tell them what all are the roles within NLP for them to fit in based on their skill set, educational background? Like we have may an engineer with no coding background, a literature graduate, or a core mathematician. What would you suggest each of them to look for as roles in the NLP?
Okay, that's a really good question, Shruti. So NLP actually inculcates a lot of, it's a combination of multiple things, and during the course they will, in this masterclass, they are going to witness few things. So if you're just a literature graduate or someone who knows multiple languages, there are a lot of job roles that you can actually come to know once you know what are the possibilities with NLP. You can be an NLP engineer. You can become a computational linguistic, which where you know how you know about the different grammars, about different languages, and that can actually help. You can provide some information to make these, that we have a lot of applications on NLP to make it more human like, so that you can, all your tasks can be done by them. You can become a prompt engineer. Everybody, you see that people are using chat gpts nowadays. You can become a chat gpt expert, where you can actually use multiple, like you have your knowledge, like if you have mathematical background, you can actually come up with building certain models that can make your lives easier for multiple tasks. And also, like, people from various different domains, be it tech domain or non-technical domains, they have a lot of applications in terms of NLP. And nowadays they have a lot of job profiles as well, in terms of being like computational linguistic, being an NLP engineer, being someone who can work with large language models, someone who can come up with more insights and work into the architectural background of these and large language models that actually facilitate lots of NLP based tasks. So in that way, they have a lot of career opportunities nowadays.
Great, great. Thank you so much. And without further ado, let's explore the fascinating world of natural language processing. I'll hand over it to you, and please start with the masterclass.
Okay, thank you so much. I'm just going to share my screen. I hope my screen is visible to everyone.
Yes.
So, good evening, everyone. I am Dr. Mosma Firdaus. I am an assistant professor at IIT ISM Dhanbad, and I am going to briefly introduce you to what is natural language processing. So basically, everybody has heard this key term and this golden word, artificial intelligence. Everything nowadays is like selling because of this term AI, you know. And this is a very important concept and it's important field of study in your computer science. Okay. And natural language processing is a field in AI itself. So natural language processing can be referred to as a subpart of artificial intelligence. And what does it do? It focuses on enabling computers to understand, interpret, and generate human language. So basically, you're trying to make the machines as intelligent as you are, okay, by making them understand whatever you are saying, trying to interpret whatever language that you are trying to say, and obviously make them generate and reply to you in the language that you are comfortable in. So your natural language processing is basically a combination of not just the computer science but also linguistics, which is a field of language, okay, which deals with a lot of language theories, the basic grammar, and many other things. Okay, so your NLP lies in between these two fields, and like I said, it is a subfield of AI and also uses, and in order to perform NLP based tasks, you need to know certain concepts on machine learning, which is going to actually help you to perform these tasks so that you can make your machines as intelligent as possible. So it's like humans talking to the machine and being able to converse to them in the language. It's like talking to someone, not thinking it to be a machine but thinking to be a friend and being able to converse with them, and like our friends, the way they understand us, way they give us answers, the way they listen to us, your machine can be capable of doing that through your language, natural language processing. So basically, you can think of NLP as the bridge that gaps between, that actually fills the gap between human language and the computer language. Okay, so we know human language is very complex and ambiguous, just like humans, who are very complex creatures. But the computer language is basically a language which is highly structured and precise. Okay, and for everyone to understand computer language is not very easy. But if the machine can understand human language, then half of the work is done. And in order to make the machines understand human language, we need natural language processing. So the ultimate goal of NLP, okay, with NLP, what are we trying to achieve is to enable computers to perform a variety of language related tasks, such as understanding spoken commands, okay, like whatever you are saying, okay, they understand it just like humans, okay, translating languages, like from one language, you're going to another language, okay, summarizing documents, like you have multiple documents, okay, and you it's not, and in today's time we are, everybody's so busy with so many tasks to do, everybody's trying to multitask, so it's not possible for you to read the entire thing and to know everything in detail. But if you have the summary of the multiple components, multiple documents, in that way you will have the knowledge and you will be able to deal with every day in a much better way. Then generating conversational responses, just like how we humans talk, after one thing there is the next reply, then the other person is speaking, so there is a like a conversation between two people or three people in that way, like how humans are so naturally blessed to speak or have these responses in terms of conversations, making the machines try to do that. Okay, and there are many more tasks related to language that the NLP actually helps us to do. So you can see that applications of natural language processing is varied, and it's not limited to the ones that is just shown in this slide. There is language translation, there is smart assistance, document analysis, online searches, predictive text, automatic summarization, social media monitoring, chatbots, sentiment analysis, email filtering. So these are some of the components that natural language processing helps us to do. Okay, has a lot of applications into, but there is much more into it. So we are trying to define NLP and its role in human computer interaction. Okay, so NLP plays a very important role in your human computer interaction, as it allows us humans, okay, to communicate with the computers in the language that we are comfortable in. Okay, especially specifically like people from the IT background or the from technical background, they are able to converse with the machines in a very easy manner by using the programming languages or by knowing certain specific commands. But people from non-technical background will not be able to communicate with computers until unless they know the programming language. In order to make sure that this does not happen, natural language processing provides that atmosphere in which people from any background can communicate with computers in the natural language. So by processing and understanding human language, NLP allows computers to interpret commands. Like we have virtual assistants like Siri and Alexa, right? Which understand the spoken commands to perform tasks. Like we say, hey Siri, please set the timer for 5 minutes. It is going to set the timer for 5 minutes. So whatever language that I'm comfortable in, I'm able to speak to Siri or Alexa, and I'm able to get my job done. So they are able to interpret the commands that is being given to them. Okay. Chatbots provide information and assistance in real time by understanding and responding to user queries. So they can answer the questions. So you have multiple chatbots, you type certain questions, you speak certain questions, and you will get some responses from them. Okay. And they also assist decision making. So NLP applications in fields like finance, law, healthcare actually help professionals analyze and summarize large amounts of unstructured text data, aiding in decision making. So for people working in many financial domain, okay, wants to know the stock market prediction, okay, wants to know what is the how the stock market is going, how the banking in the banking sectors, how likely people are supposed to do one thing or one job or something like that. In the law, how are we going to actually decide what type of punishment to be given, whether a person is guilty or not guilty. So in decision making also, NLP plays a very important role and has varied applications. So basically, NLP you can think of is like making technology accessible to non-technical users by enabling computers to handle nuanced language tasks, ultimately improving usability and interactions in various applications. So before going into the details of what is NLP, I'll give you a brief timeline of NLP. So in the 1950s is the time when people actually started investing or investigating into this field. Okay, so in the 1950s, people had interest in translation. So this is the time when World War II has ended. Okay, and the time when Cold War actually started, and people, specifically the US government, was very much interested in translation of language. They wanted to know what is happening so that they could increase their defense forces. Okay, so in 1950 there was an interest in translation. There was Chomsky came up with the syntactic structures. There were people working on generative grammars. By the time 1960 came, Eliza was designed. Eliza is the first chatbot, which is a rule-based chatbot that was designed in 1960. And then there was an ALPAC report, which was a committee who actually tried to see whether or not people who proclaimed that they are going to work on translations was able to, work in translation. What was the results? And then we had the first AI winter, where AI winter is basically the time when AI actually wasn't doing very well. Okay, the time when people lost faith from artificial intelligence and did not wanted to be associated to artificial intelligence in whatsoever manner. Then in 1970s, we had some more work into grammar, networks, and the conceptual dependency theories. By 1980s, we had the ontologies, basically the way we try to, manage things, or the way you can think ontologies to be something like some sort of organization systems. And then we have expert systems, where there were systems which were designed for particular tasks, and they were experts in performing those tasks. By the 1990s, we had certain statistical models, we had some RNNs and LSTMs which were designed to work on NLP based tasks. From 2000 onwards, we had people focusing on language modeling, like how we can understand language, how we can predict what next can be said in if a given context of words, what is the next word that can be predicted. Based on this, we can know, like when you're trying to type something, you see right now, when you're trying to type a message, there are certain suggestions that you get by default. So this is basically referred to as language modeling. People focused on word embeddings, and the Google translation team actually started making some promising work in the terms of translation based tasks. From 2010 onwards, we had certain word to vec techniques. There was a rise of LSTMs and CNNs, encoder decoder architecture. Then came transformers and pre-trained models. And from 2020 onwards, we are living in the era of large language models and GPT-3 based models, where everybody is trying to make sure that all the tasks that we are trying to do is basically done mostly by our large language models. So this was the rough timeline of your NLP, but there are certain challenges that you face when you're trying to work on natural language processing. One such challenge is your precision and ambiguity. Okay, we know, we as humans, we are sometimes confused when people are saying something and we are not able to understand that. So you can understand how difficult it can be for a machine. Then the tone and inflection. Okay, trying to identify sarcasm or trying to know whether or not someone is being emotional or something, or that sometimes it gets difficult for us humans. So similarly, you can see how it can be difficult for the computers to understand the tone and the inflection from certain texts. Then we know language is an evolving phase. Right now people are working in short forms. There is some new language lingo going on, so we ourselves are adapting to this, and we ourselves are increasing our vocabulary every day. We are ourselves getting to know about new words, new terminologies, based on which we are evolving the way we communicate with others. So making computers understand that is also going to be a difficult task. Then we have dialects and accents, we have bias in data, and therefore the informal language, right? Like the way people talk in social media. Okay, like in your X, in your Instagram, in your Facebook post, your language is very informal. It's not structured in a proper way. There is short forms, there is different way of writing, and everybody have different ways of writing. So there is a lot of challenges when you are actually trying to work with natural language processing. So we are going to understand what are the major challenges that we face in natural language processing and why it is so challenging. Though it seems like, okay, we are trying to just make the computer understand human language, that's not a big task. Okay, but from the human point of view, obviously it's not a big task, because we are designed in a way that we naturally understand the language. Okay, but then again, for us, understanding a new language is a task. So you can consider it and you can think of it like you're trying to understand a new language. So for computers, understanding language is like for us trying to understand a new language. So it becomes very difficult because we don't know the different words, we don't know the meaning of those words, and we don't know many other things which can complicate the task of understanding a new language. So, first and foremost problem or the challenges in working with natural language processing is your ambiguity in language. So, what do we mean by ambiguity? Ambiguity means human language, as we know, is filled with words and structures that can have multiple meanings and depending on the context. There are three main types of ambiguity in NLP. First is your lexical ambiguity, okay, which means that one word has multiple possible meanings. For example, the word bank can refer to a financial institution or the side of a river. Okay, we also call the side of a river as a river bank. So, in the sentence, he went to the bank, we will never be able to know from this sentence alone that whether he went to a financial bank to do some financial transaction, or he went to a riverbank to just spend a day. So just from this particular sentence, we don't know which bank he's talking about. And when we are not sure about which bank he's talking about, this tends to bring in the ambiguity in the sentence, and hence this is referred to as a lexical ambiguity. So, like I saw bats, whether you are talking about bats as an object or bats as animal, we are not sure from just the sentence until unless we have the images associated with it. Secondly, there is the problem of syntactic ambiguity, where when a sentence has multiple possible grammatical structures leading to different interpretations, like you are going to change your sentence, you can break your sentence, and that might lead to possible meaning. Okay, for example, the sentence "I saw the man with the telescope" can mean either that I saw the man means I used a telescope to see the man, or I saw a man who had a telescope. So from one particular sentence, you can have two possible interpretations. Okay. So this refers to as your syntactic ambiguity. And finally, we have our semantic ambiguity, which occurs when the overall meaning of a sentence is unclear, even if each word is understood individually. Even if we know every word in the sentence and still the overall meaning of the sentence is unclear, then we refer to it as semantic ambiguity. For example, visiting relatives can be annoying is ambiguous, as it could either mean that relatives who are visiting is annoying, or that relatives who visit can be annoying. Okay. So when the overall meaning of a sentence is not understandable by the sentence itself, then it is referred to as a semantic ambiguity. So ambiguity is one of the major problem with NLP, but that's not where it ends. We have more such complexity in languages that makes natural language processing a very difficult, challenging task now, even today. Okay. So we have beyond ambiguity, we have something called polysemy, homonymy, and other contextual dependency, which further complicate natural language processing tasks. So these complexities require a nuanced understanding of the language that is challenging to model computationally. For example, polysemy refers to a single word having multiple related meanings. Okay. For example, the word run has many meanings such as to run a race, to run a business, or a computer program run. So run can have multiple meanings on based on multiple things. Okay, you can run a race, you are running a business, you are running a computer program. All these meanings are related, they apply in but different context. Then we have homonymy, okay, which occurs when two words have the same spelling or pronunciation but different unrelated meanings. Like bat can either mean a flying mammal or a piece of sports equipment used in baseball. And then we have something called context dependency. Okay. The meaning of many words and phrases depends heavily on the context in which they are used, making context a crucial component in NLP. So for us to understand, to make understand what actually is being said, we need to focus on the previous words. Okay, we need to know the context in which those words are being said, so that we can understand the language in the much better way. So for example, the word cold can refer to temperature, an illness, or a lack of friendliness. Without understanding the context, it is challenging to determine the correct interpretation. Okay, whether he is suffering from an illness, like he's got cold, or whether that it is too cold for him to even step out of the house, or he was cold when he met me. Okay, can be based on the remaining words, we can understand what actually cold means. So there is a dependency on the other words, which means we where other words formulate to become your context. So in that way, this is where language has more complexities. Then there are some additional complexities like dialects and regional variations. So from people from different uh, language group or regions speak in different dialects, okay, which again can cause problems. For example, in American English, the term elevator is used. Okay, while British English uses lift for the same concept. Okay, subway in American English refers to underground transit, while in British English it means a pedestrian underpass. So a same word is having different meanings based on the region or the place from where it is being used. Then there is code switching, where there is the practice of mixing language or dialects within a single conversation, which is very much prevalent in today's days. When we are writing a post, when we are commenting on someone in social media or anywhere, we mix languages. We talk in English, even in our day-to-day conversations. We tend to talk in code mixing way, okay, in which like we are talking in English where we use some Hindi words, or we are talking in Hindi or in any of our mother tongue and we are using words of from another language, okay. So, for example, in multilingual communities, people may switch between languages, as in English, which is nothing but Hindi and English. Let's go to the mall and do some shopping, yaar. Okay, so here this word yaar is actually belongs to Hindi, but it is being said in a sentence where most of the words are English. Then we have something called sarcasm and irony. We know sarcasm and irony involve saying something that means the opposite of what the words convey, often in a humorous or critical way. Okay. So, for example, oh great, another traffic jam. Your great is used sarcastically to mean the opposite. Nobody's happy with a traffic jam, but it is said in the opposite context. So some for us to understand this is easy, but then again for a computer to understand this can be difficult. Then we have a lot of idiomatic expressions that we use, okay, which means something, okay, the literal meaning of that sentence or that phrase is something, but actually it is used or it means something else when used together. For example, kick the bucket means to die, not to actually literally kick a bucket. Okay, so there are certain idioms or certain proverbs that we use in day-to-day life where the literal meaning of the individual word actually does not make the phrase mean the same thing. So with these complexities in mind, okay, there is you can understand how difficult it can this natural language processing is, okay. And in language, when we are talking about natural language processing, language is the key term. And like we know, language has got many levels, okay. Like how you started learning language, for example English, you started with your alphabets, then you went to forming words, then you went to forming sentences, from the sentences you went to forming paragraphs, essays, and you are able to understand the particular language, okay. So there are different levels of language as well that we know of. First is the phonetics and phonology, where all sounds and system sounds basically you can refer to at layman terms as being alphabets. Then we have morphology, where we have forms and words, okay. Then we have syntax, which is clause and sentences. Then we have something called semantics, meaning of various kinds. And finally, we have pragmatics, which means language use. So the main three things that we focus in natural language processing is the syntax, semantics, and pragmatics. So syntax refers to the grammar and structure of sentences. It refers to the rules that govern the structure of sentences in a language. It tries to define the words in like arranged to form some meaningful sentences and phrases. So there are key concepts in syntax, like your part of speech. Like initially when we studied language, specifically English language, we were introduced with these terms like nouns, verbs, adjectives. So these were parts of speech. So similarly, for the computer to understand language, it needs to know the syntax, and hence it needs to know about the different parts of speech. Then comes the phrase structure, like whether it's a noun phrase or a verb phrase. That is something that the computer needs to understand, just like we need to understand for any language. Then parsing is a process of analyzing a sentence to determine its grammatical structure. And there are two common types of parsing, that is dependency and constituency parsing, which actually helps the computers to understand the grammar and to make the sense of a particular sentence. Then we have semantics, which refers to the meanings of words and sentence. Okay. So semantics basically deals with what that words actually mean. Okay. So it is concerned with understanding what the text is about, going beyond just identifying the structure. Just knowing that it's a noun or a verb is not enough. What does it actually means, that is enough. So in NLP, semantics is critical for interpreting the content and answering questions. So We have certain concepts, which is your lexical semantics, which tries to understand the word meanings and relationship between different words, such as your synonyms. So you know, like, these are similar words which have similar meanings, antonyms, words which are opposite in meanings, and polysemy, words with multiple related meanings. Then we have a key concept in semantics, which is your word sense disambiguation. Like we have seen the problem of bank. We don't know from the sentence itself what bank it refers to. Okay, so we need to understand, we need to get the sense of that word. Okay, which is basically one of the important tasks in NLP, trying to find the sense of the word and disambiguate between the different contexts. Then we have named entity recognition, which identifies and categorizes entities like names, location, dates, and organizations in a particular text, trying to make the sense of what each word actually means. Then we have pragmatics, which is language in context, trying to know the intent or social cues. So, pragmatic involves understanding language in context, which is actually crucial for interpreting the intent, what is being said. Okay, so this pragmatics is like a step up from your semantics. So, we firstly have the syntax, trying to understand verb, noun, what it is. Then we have semantics, trying to get the meaning of, if it's a noun, then what does that word actually mean, whether it's a place, it's a location. That is what semantics mean. Now, pragmatics is going ahead. It is going more than the literal meaning of the words and sentence, to consider how language is used in the real world scenario. Okay, so we have our contextual meaning in pragmatics. So can you pass the salt is literally a question. Okay, but pragmatically we know it's a request, right? We know that somebody is requesting us to pass the salt. Okay, then we have implicature, which means, like, from a particular sentence we imply something. Okay, it's getting late. So we know if someone is saying it's getting late, they mean that they want to leave. It's time for them to leave. So instead of directly saying that I want to leave, somebody says it's getting late. So you are trying to understand the intent of the sentence from the given text. And finally, we have dexes, which depend on context to convey meaning. Like, these includes your words like this, that. In the sentence, let's meet here tomorrow, I don't know what here and tomorrow means. Okay, so it depends on the speaker's location and time of the statement. So these expressions again belong to, which is actually trying to understand something more than the actual literal meanings of the word, but it actually means some social clues based on which you're going to interpret what this place is going to be, and actually which day it is. Okay, so you can understand these are the three different levels of language that is important for you to understand, for the machine to understand, so that it can solve any NLP based application. So we have certain core NLP techniques. Firstly is the text processing. Okay, so NLP, like we know by now, we know that it depends on language. So language is basically some sort of text, and in order to work on text, you need to do some sort of pre-processing. Okay, so working on raw text in itself is very going to be very difficult. So you need to make sure that you transform your raw text into some usable format, so that they are consistent and can be meaningful. So there are some key pre-processing techniques, like your tokenization, which is the process of splitting your text into smaller units. So you can do word level tokenization, where you are splitting a particular sentence at word level. Then you have subwords tokenization, where you are breaking a sentence into some phrases or some smaller parts. And you have sentence tokenization, when you are doing is done when you have a paragraph and you want to divide that paragraph or document into individual sentences. Then we have stemming and lemmatization. Both techniques aim to reduce the words to their root or base form. So stemming strips suffixes to obtain a rough base. Like we know, running, runner, runs, all are coming from run. So getting the base form of that word is referred to as stemming. Lemmatization uses linguistic knowledge to reduce words to the dictionary root or lemma. For example, running becomes run and better becomes good. We know better is actually a form of your good, and hence it is being reduced to good. So these techniques ensure consistency in text data, especially for tasks like information retrieval, where words with similar meaning needs to be treated the same way. So there are multiple tools that is available for us to do these type of pre-processing for language for any NLP based application. We have NLTK, which is a natural language toolkit, which offers tokenizers, stop-word removal, stemming functions, making it a powerful tool for text preprocessing. And we have Spacey, which is a popular NLP library that provides efficient and accurate tokenization, POS stacking, parsing, so that we know the grammatical structure and we can do some more high-end tasks from these for any natural language processing application. So now we have understood what is language. Now we know how we can process a text. Now the most important thing is word embeddings. Okay, so everybody, I hope, knows, or even if you don't know, computer understands only numbers. Okay, it understands numbers. It does not understand words whatsoever. Okay, so how does actually a word get converted into numbers? So the words actually gets converted into numbers by using some sort of embeddings. Okay, so every word is translated into a number based on the embedding form. Okay, so word embeddings are nothing but some dense vector representations that capture the semantic relationship between words by mapping them to a continuous vector space. So vectors are basically a concept in mathematics, okay, which represents a, a way of representing a number. Okay, so word embeddings are said to be dense vector representations that actually captures the meaning or the relationship between different words. So initially, bag of words and TF-IDF, which is the key concepts in machine learning, was actually used to represent words when dealing with these, for dealing for any natural language processing tasks. But the problem with these techniques were that they were not able to capture the meaning of the words, and they were not able to capture the relationship between the words. They were only able to capture the information of whether a word exists or not exists, or how many times it exists. Okay, so here the problem, the connection between the different words were lost. Hence we have the word embeddings, which allow NLP models to understand word relationships and semantic similarity, enhancing performance in many downstream tasks such as sentiment analysis, machine translation, and information retrieval. So there are different types of word embeddings available. For example, your word to wear, glove, Elmo, fast text. These are different types of word embeddings that are available nowadays, with which you can map the words into the numeric form, and you can provide it for your any NLP based application. So you can see this is the vector space that I'm talking about. Okay, every word is actually represented by numbers, and it can be plotted in this vector space, where man and women, they are close to one another. Okay, but not very close to one another, because obviously they mean two different genders. Okay, now king and queen, again they are slightly apart, but again they belong close enough to one another because they come from one similar context. Like walking and walked, swam and swinging, they have some sort of association. So every word is having some sort of association, and that is actually being captured using these word embeddings. Now, in order to perform this natural language processing based task, you need to have certain computational models which are able to make or automate or make the machines actually understand what the humans are doing. So there are multiple tasks that we have already seen, applications of NLP, okay, which will go in detail a little more. But in order to perform these applications, you need to do have some computational requirements, and one such requirement is deep learning. And deep has been introduced for NLP late in the 90s, and has actually transformed NLP by allowing the models to learn the different complex patterns and relationship in the data. So deep learning basically uses neural networks which can capture sequential and contextual information, making them suitable for NLP tasks. So we have certain deep learning models such as RNNs, okay, which are designed for handling sequential data. So basically RNNs were designed to work on natural language processing based data set, that is text which have some context, like one word follows the other. So in order to capture this sequential information, RNNs were designed. Then we have long short term memory, okay, which is called the LSTMs. These are also a type of RNN which was designed to again work on sequential data. So RNNs actually have certain issues, certain limitations. In order to overcome those limitations, LSTMs were designed, and they are used widely for a lot of NLP based applications such as your machine translation, text generation, sentiment analysis, where they are capable of capturing certain long range dependencies. Dependencies, we means the context that they are able to carry. So during these time, we have the RNNs and LSTMs, but in 2017, the field of NLP got revolutionized by the introduction of transformer models. Okay, so NLP transform models is actually revolutionizing language processing. The way people are able to understand languages has increased exponentially from the time NLP or the transformer architecture has been introduced. So transformers are type of again neural network architectures that replaces an RNNs, and they focus on one basic concept, that is self attention. Like we know attention is important. If you want to know something, if you want to understand something, you need to pay attention to it. So based on this simple concept, we have the transformer architecture, which tries to make sure that each component of a particular sentence is attended, is given attention, so that it can perform very well. Okay, so there are a lot of applications of NLP that are being done using these transformers model, and transformers are actually the foundational modern NLP models that you hear about your chat GPT or BERT or different based NLP based models that you're using, that you hear about. They all are being the foundational model that is designed, like the basic unit of all these models are your transformers. So all these different tasks that you were able to do before, now you can do using your natural language, using your transformer model.
Dr. Firdaus,
Yeah.
Arpana is asking that NLP is a part of deep learning.
No, NLP is not a part of deep learning, but deep learning can be used to solve NLP based tasks. So basically, they go hand in hand. Like you can think of like you have a machine, okay? You want to work on a particular machine, okay? So suppose I want the Siri to switch on the fan for me, okay? So I am giving my commands to the Siri, but actually Siri is doing some sort of processing through which it is able to interpret my command and it's able to perform the task. So this interpretation of the command and to be able to do the task, that is being done by the deep learning. Okay, so deep learning is basically the technique used to solve any NLP based application. So that is what deep learning is. It is basically help. So basically we have NLP can be done using some rule based system, your statistic based systems, okay, your machine learning based concepts, okay. But nowadays we have deep learning based concepts, which has actually revolutionized the field of NLP, where it is able to understand the language in much better format. I
And
hope.
yeah, it is here. Really nice.
Thank you.
So, Francis is asking, will you teach us the Python in the course? Python is available as an add-on course, Francis. So you will learn once you join the course. And beside this, one more question. The students are mostly asking that we are from the computer science background. So is it beneficial for us, NLP? Or most of the students are asking that it is useful for HR also.
Okay, so if you are from your computer science background, then NLP is actually very, very beneficial for you. Even for people who are working on HR based like fields, for them also you can, like NLP has a lot of applications. Okay, so in that case, like for I can speak about from computer science background, you will have a lot of job profiles. All these big companies that you hear of, Google, Amazon, Facebook, OpenAI, all these are basically looking for NLP engineers who can work on these different tasks in NLP and can work on, still work on it. Till now your Google Translate is not perfect, it cannot handle all the languages. So you have a lot of scope in which if you know about the different concepts in NLP, you can actually get some, you can land up with some great jobs. You can come up with your own startup, you can think about different applications where you can use NLP. So there is a lot of opportunities with NLP actually.
Great. Please continue with your class.
Okay. So here I want to briefly talk about some of the real world NLP applications through which you will actually understand that how NLP is actually helping. It's not just about language, it's not about grammar, it's not about knowing the meaning of the word, but actually there is some applications that you can see that you have day to day. So, one of the most important applications, NLP has actually a wide array of applications, but transforming industries and enhancing user experience is some of the most notable applications of NLP. So, if you are working on HR based profiles, you want to increase your client, you want to increase your the number of opportunities, the number of people who are actually you can grab your hands into so that they can work for your firm. People who are working in the IT field, they want to transform the industries, how the way the world is revolving. All this you want to do, and you can do it through NLP. So chatbots and virtual assistants, all these chatbots and virtual assistants that you see, like your Siri, Google Assistant, and Alexa, they all rely on NLP to understand the user queries and respond appropriately. So they are programmed to understand a wide variety of natural language inputs, providing information, performing tasks, and interacting with users in a conversational manner. So the key NLP techniques that is being used in these chatbots and virtual assistants is basically your speech recognition and synthesis, identifying the intent of the user sentences, then your dialogue management for maintaining coherent conversation. For us humans, it's easy. We converse, we know. But for the machines to maintain the coherency between the languages, that is basically done by NLP. Then we have machine translation. Okay, machine translation systems such as your Google Translate enable automatic translation of text or speech from one language to another. These systems have improved dramatically due to the advancements in NLP. So there are a lot of NLP techniques. We have neural machine translation, we have sequence to sequence learning, and we have transfer learning to support multiple multilingual models. I'll just show one short uh, demo. Okay, so here I have already provided my language, which is English, and I have provided Hindi. And here I'm asking it to translate from English to Hindi. And my sentence is, I'm tired of working today. So it is going to analyze this sentence and it is going to translate this sentence into the Hindi meaning. Okay. So just give it a fraction of time. Uh,
Asham is also asking Dr. Firdaus regarding the relationship between NLP and machine.
NLP and machine. So basically, the relationship between NLP and machine is that your natural language processing, NLP is basically trying to make the machine understand the natural language. Like, for example, if you want the machine to understand your language, okay, right now your Siri is only working with English, but you want to have a chatbot which can understand. If for example, my mom wants to work on use the machine to get her jobs done, she cannot communicate in English, so she would want the Alexa or Siri to understand Hindi. So for Alexa Siri to understand in Hindi, I need to convert my English to Hindi, okay, and then make sure that the Hindi word is actually understood. So the semantic part of understanding of that command, that is your NLP, okay. That conversion from one language to another, that is your NLP, okay. How you're doing it, the technique, that becomes part of your deep learning or machine learning. Okay, so here you can see there are different models which has converted the language. I am tired of working today, मैं आज काम करने से थक गया हूँ. Okay, there is different models. You have chat GPT, you have, these are different models who have tried to convert that particular language into the another language. Okay, moving forward. Okay, we have another important task, which is your sentiment analysis. Okay, which is used to determine the emotional tone behind a body of text, such as a customer review, social media post. So for example, if you have a particular sentence and you want to know whether that sentence is positive or negative or neutral, you can do that using your basic, using some of your NLP techniques, such as your feature extraction. So there are many advanced deep learning models that can do sentiment analysis for us. So basically, if you see this demo, I'm going to write this particular sentence: great product, perfect length, and cut to wear with my leggings. This was recommended by my consultant. Okay, this is the sentence. Okay, I am going to check whether or not this is a positive sentence, negative sentence, or is it a neutral sentence. So I am getting the answer as it is a positive some sentence. So this document is positive. Okay. And why does it is this referred to as positive? Because of the usage of the word great, product, recommended, great, perfect. So these words that is contributing towards understanding that this sentence is your positive sentence is actually part of NLP. Okay, the semantic analysis of these words is what NLP does. Moving forward, we have information retrieval and search engines that you have your Google. Okay, where you are writing your comment, your whatever you want to know about, you just Google it, right? So when you are Googling it, your term that you are typing uses NLP to understand the queries and retrieve the relevant documents. So NLP is basically behind every search engine. Okay, so it's not just doing some sort of keyword matching, but it is also understanding the user intent and ranking results based on relevance. So there is a lot of concepts of NLP, that is parsing, there is query understanding, then there is semantic understanding to interpret the what the user is questioning about and providing the possible results. Then we have text summarization, okay, where actually it automatically creates a concise summary of larger text documents, which is particularly useful in journalism, legal, and academic fields. Suppose if you have a textbook, you have one chapter, and one day before the exam, it's not possible for you to read entire chapter. If you get a summary of that, what that chapter says, it becomes easy for you. Right now there are multiple things going on across the globe, right? And if you want to know the information about everything that is happening across the globe, what would you need? You would need that you provide all your newspaper information and you want to get a summary of the headlines, okay, or what is the main news that is there, and that is what it will provide to you. So in that way you are being actually at the top of your game. So I can show you one demo over here. So this quill bot is actually an NLP based application. Okay. So for example, if I write this sentence, mm, okay.
Dr. Firdaus, one of the Saswata is asking that what are the job roles after learning AI/ML or basically NLP for a MCOM marketing student?
Okay, so if you are doing MCOM and you want to know about if you what are the job profiles, you can become like if you know multiple languages, okay, then you can become a multilingual NLP specialist where you can help with fine domain NLP task. Okay, you can become you can work on different NLP based products. Okay, like your language recommendation system, your chatbot systems where you can work. Okay, you can become data analyst using NLP or NLP data scientist, which is more language focused, where you analyze text data and you based on that you provide certain solutions. You do some sort of identification of those data, means some sort of analysis of the data so that it can help in which way the data is modeling. So that way you have multiple roles. Okay, you can become chatbot developer, you can become a computational linguistic, okay, where you can combine the knowledge that you have of particular language, the linguistics of that language with computer science, and you can work on different product based applications.
Great. And most of the students are asking for the recording and PPT. So you will get the recording on our Jobinar page, and the link will be shared soon on the chat. And beside this, you'll get the recording, and that will you will get it after few days.
Okay, so
So I request my team to share the link of the Jobinar page.
okay, I'll just quickly finish off with the emerging trends in NLP. So, if you have heard about right now, everybody is talking about. If you recently seen the US the market actually went down because of known large language model, some new large language model, which is the DeepSeek. Okay, so you can see how the world is revolving because of these large language models. So basically, one of the emerging trends in NLP is basically exploring large language models. And with these large language models, you don't have to be any expert in computer science or very good programmer. You can use some sort of prompt engineering, which is one of the most used technique, where you are designing how you are prompting, how you teach a person. Okay, by giving few examples, you are teaching someone to do a particular task. So you can do a lot of tasks, okay, just by using some sort of instruction tuning and prompt engineering in these large language models. Okay, so right now large language models is kind of basically they are pre-trained models. Okay, so you can use these pre-trained models and you can fine tune for your own task. Suppose it has been trained for some general English data and you want to fine tune it for some particular domain, like you want to fine tune it for a healthcare domain, for an educational domain, for a sports domain. So any application that you want to work on, you can fine tune your large language models based on that. Okay, then we have multilingual and cross-lingual NLP. Okay, where we have a lot of large language models who can still handle multiple languages but not all the languages. And there are very low resource language focus, like for example, after English, Hindi is the most spoken like language in India. But there are many other languages. There are around 26 languages, more than 26 languages in India. But all those are mostly low resource. Okay, so building NLP based models for them can actually increase and make people access these tools in a much better way. Then we have responsible and trustworthy NLP, making sure whatever models that you are creating are fair and does not have any bias in them. They are able to interpret and explain what decisions they are taking. Okay, so that like how we humans are able to reason out. Okay, so making sure that the tools, the NLP application, the chatbots, or whatever application that you're building are ethical and are safe for deployment, are fair and without any bias. Then we have knowledge integration and reasoning. Okay, trying to incorporate, like if you want to work, if you want to make a chatbot for a medical domain, okay, if you're wanting to make a normal chatbot, it's fine. If it even talks rubbish, doesn't make a difference. But if you want to make a chatbot who is going to assist a doctor in making decisions, okay, who's going to make the task of a doctor much easier, you need to incorporate knowledge into the machine, into for that particular chatbot. So knowledge grounded language models or knowledge integration is a key trend that is going to actually take NLP to next standards. Okay, then there is chain of thought prompting, where you are trying to think step by step and solving a problem. You're combining a lot of rule based logic, symbolic logic. You are trying to making the machines think more like humans. And finally, there are a lot of domain specific NLP applications, like I said, healthcare and biomedical, where you are trying to work on patient records, medical literature, and trying to make applications for the healthcare domain. Legal tech, okay, someone who can help be a legal counselor, an online legal counselor for a financial institutions, for customer service. Okay, so all these, like right now you have seen your Swiggy, Zomato, your Mintra, all these are having a customer service. So there is a chatbot. If you have any problem, you are chatting with that person. Okay, so initially the first few conversation that you are having is basically with a machine. There is no human who is responding to you. Okay, eventually there is a human if the complexity of your issue is high. So initially the chatbot, the person that you're conversing with, is actually an agent who is basically designed using these NLP based techniques. So with this I like to stop today's masterclass. Thank you for attending, and I hope you get interested with the applications that NLP has to offer and the future trending goals that NLP has yet to come. It is actually approaching towards those goals, but still it's not there. So basically, NLP is trying to make sure that your machines are able to think like humans, behave like humans, and actually are able to converse like humans in all types of human languages. So, with this, I would like to thank everyone for joining this session and attending this masterclass.
I would like to, there are so many questions from the students right now, but I would like to take up quick questions. One of the student is asking that I have created a chatbot for my Python job portal, but can you tell me only he uses the button options. So is there any way to advance it?
Yes, there is multiple ways. Firstly, if you have certain knowledge about coding, okay, you can use your these large language models, okay, and create a demo of your chatbot, okay, which is not just working on your buttons format, okay. So basically, if you want to create a chatbot, there are multiple things in creating a chatbot. Firstly is there are multiple components. Firstly is you need to understand what the user is saying. Then you need to make sure whatever the user has understood, you need to give it to the dialogue manager, which is going to communicate with the database and with the human itself. And then you have to generate and give it back to the response to the user. So there are multiple components, and all these components can be intertwined and can be linked using any deep learning based approach. So you have to create your data, or whatever data you have, and based on that, you have to train a model based through which it can actually perform and work like a automatic chatbot rather than just the button systems. So there are lot of key concepts which you will understand.
Now, the last question I'm taking from Narsimha, and that is I'm from BTech third year student and I want to work in NLP. So, what's the way to join as NLP engineering or any other role?
Sorry, I didn't get the question. A question.
Uh, Question is like he's asking that I am a right now BTech third year student and I want to work in NLP field.
Okay.
So, what ways to join as an NLP engineer or any other role?
Okay, so basically, right now you are in your third year. So I would suggest that you should engross yourself. You should take interest in more NLP based app. Like I've showed multiple applications, right? You have machine translation, summarization, text analysis, sentiment classification, your chatbots. So try to take one application and try to focus on that application. See what you are understanding, whether you can are able to replicate those applications by yourself. And if you are able to, if you are actually interested, like you will be going in your fourth year and you will have to do a BTP project. So if you are able to take your NLP based project as your final year project, and you actually perform that, and if you and then you can put it in your CV, and people actually are hiring, coming companies are looking for NLP and ML based engineers. So that way you will get your job profile in that particular field.
So providing a specialization in NLP. So
Yes.
you can choose that domain also.
Yes.
So, with I, uh, Tushar is asking one interesting question that in sentiment analysis, comment as positive, negative, normals, every type of comments will come up.
Yes, for any comments, if you give the sentiment analysis task will tell you whether the comment is positive or negative or it is neutral. Okay, so there is more towards it. Like you can also understand based on, like for example, if you have a sentence, I like the food, but I did not like the ambience. So this is like is going to have two sentiments, right? So based on what you are talking about, your sentiment changes. If you're liking the food, then it is a positive sentiment, but you don't like the ambience, so it is a negative sentiment. So that is referred to as your aspect based sentiment, where you can have two sentiments based on what aspect of that particular product you are talking about. So that is also there, but for any given sentence, any social media post, you can know about the sentiment.
So that's a really wonderful explanation, Dr. Firdaus. It's really our pleasure to have come on this platform. And the way you have been taking this session, the masterclass, it's really indeed a true masterclass. Thank you so much. So that's a wonderful session. So with this, we have come to an end of the session. In case if you all have any more doubts, any more questions, you all can always reach out to us. And I want to especially thank you, ma'am. It's been a pleasure to be here in your masterclass. The way that you explained and summarized everything, it was really awesome.
Thank you so
Once
much.
again, once again, I would like to reiterate few things. As a part of this program, we offer a series of masterclass led by our expert professors. So don't miss our next masterclass on 13 Feb and you will receive the invite soon. Also, I urge you to all make most of this, use the opportunity, this opportunity. If you buy this course before 8th Feb, so you will eligible for the special 10% discounts. So I urge you all, please, if I were you, definitely I'll go for it. So there is a promo code also available, that is TCS iON IITISM D10. So thank you, audience, for your active participation, and absolutely thank you once again for your time and presence. Thank you, Dr. Firdaus. So
Thank you,
I,
everyone.
Shruti Khurana, signing off. Have a pleasant evening.
Thank you, everyone. Thank you for joining.